Part 2, Square Roots of a Function. Up until now, our discussion has been primarily on transformations of the basic square root function graph. Okay, the discussion now shifts to the square root of an entirely separate function. So if we start with some general function, y equals f of x, then the square root of that function would be y equals square root of f of x. The mapping rule for this transformation is simply xy transforms to the point x square root y. So really, remember how f of x is just y. Okay, so the new y coordinate is just the square root of the old y coordinate. Anyways, all good. Okay, so remember, we can't take the square root of negative values. Okay, so the function, the new function, will only be defined when f of x is bigger than or equal to 0. If we consider the graph for y equals f of x, just the original graph, anytime the graph has negative y values, the graph of y equals root f of x cannot exist. So let's show you an example of how this works, and hopefully it'll make a little more sense. So, given f of x equals negative 1/4 x plus 1, graph the functions f of x and y equals root f of x. So I've got a table of values ready for you. You really don't need them for the line, but that's okay. So what we're going to do is let's just fill in the table of values. And okay, so when x is 5, okay, so negative 1/4 times 5 is negative 5/4 plus 1, so that's going to be negative 0.25. 0.25. Okay, when x is 4, y is 0. When x is 3, y is 0.25. When x is 2, y is 0.5. Okay, and I'm just typing these into my calculator. I've already obviously done these already, so this part can be faster, but that's how you do this. You just type it in. When x is 0, y is 1, 1.25, and then 1.5. Okay, so we can graph these. Now, you don't have to do that with just the points, because you know that the y-intercept is 1 and the slope is negative 1/4, which means we go down 1 and 1, 2, 3, 4 over. Okay, that's great. So, and then 1 up, 1, 2, 3 to the left. So those are some good points there. Let's see how steady my hand is. Not the greatest, but not terrible either. Okay, so there's the graph of negative 1/4 x plus 1. Okay, let's see, we could put, so that's 0.25, that's 0.5, that's 0.75. You get the idea. Okay, so now the square roots of these things, though, remember, you cannot square root a negative. So this guy is undefined. Okay, he doesn't work. Okay, so the square root of 0 is 0. Square root of 0.25 is 0.5. Square root of 0.5 is 0.71. Okay, square root of 0.75 is 0.875 or 87. Square root of 1 is 1. Square root of 1.25 is 1.12. And square root of 1.5 is 1.22. Okay, so let's graph those. So the first point, here I'll graph in orange. Okay, the first point was 0, 0. Remember, down here at 5/2, okay, the graph couldn't exist. So in fact, all of this, these y coordinates are all negative, so when you square root them, you can't square root them. So the graph of root f of x doesn't exist down here. Okay, so it does exist here, so 0, 0. Okay, now, when x is 3, When x was 3, it was 0.5. So 0.5 is about there. Okay, when x is 2, we are at 0.71, so that's about here. Okay, then we are at 0.87, which is about there. Okay, at 0, it's 1. Oh, look, there's 2 intersection points here. Okay, and then at -1, we were at 1.12, so that's actually down here somewhere, and then 1.22 is about there. So if we connect the dots here, again, let's see how steady my hand is. Just like so. Okay, and there's a couple of really interesting things about this graph. The first of which, the orange graph doesn't exist when the blue graph is negative. Okay, it just doesn't when the blue graph has negative y coordinates. Okay, now there's a couple important things here in between the points, the y coordinates of 0 and 1. Okay, see how the orange graph is bigger in between 0 and 1? That's because the square root of numbers less than 1, the square root of them are always bigger. Okay, and then after the y coordinates get bigger than 1, the square root of a number bigger than 1 now works out to be smaller than it was before. So for instance, the square root of 0.5 was 0.71. So the square root of 0.5, so 0.5 is there, the square root of 0.5 is higher because it's bigger. Okay, down here though, the orange graph is lower than the blue graph because the square root of, say, even if we go all the way up to 4, square root of 4 is 2. So anyways, so comparing the two functions, okay, there's that part that doesn't exist. Okay, and for the first little bit, the square root graph is higher, and then the square root graph will be lower for the rest of it. Okay. So, important features of the graph y equals f of x. So the domain of y equals root f of x consists of only values of the domain of f of x for which f of x is bigger than 0. Okay, the range of root f of x consists of the square roots of the values in the range of y equals f of x for which root f of x is defined. Remember, we can't square root negatives. That's so important for this. The graph of y equals root f of x exists only when f of x is bigger than 0. Okay, and you can predict the location of y equals root f of x relative to just f of x using either a table or a graph. Okay, and then this part here, this little table, okay, that shows that relative position higher or lower. Okay, so value of f of x, so this is basically the value, the y values. Okay, relative location of the root f of x graph. Okay, so if f of x is less than 0, so that's when the blue line has y coordinates, okay, then the graph of the orange line, or the root f of x, would be undefined. You can't square root negatives. Excuse me. Okay, now for when f of x equals 0, so when the y coordinates are 0 on the graph, the root graph, okay, the square root of 0 is 0, so those are intersection points of the two graphs. Okay, when the original graph has y values between 0 and 1, the square root graph is higher, or above the original graph. Okay, at y equals 1, the two graphs intersect again, and when f of x is bigger than 0, then root f of x is now smaller for the rest. Okay, let's try some examples. Okay, compare the domains and ranges of f of x and root f of x. Okay, identify and compare the domains and ranges of the functions in each pair. Okay, so we have y equals 2 minus 0.5 x squared, and y equals root 2 minus 0.5 x squared. Okay, not a big deal. It's kind of what we expect from these things. So what's easiest to do is to graph these things. Now you can graph them on your graphing calculator. That's probably easiest or best, but I'll just make a quick sketch of what that looks like when you see it on your calculator. Okay, so this guy here, that's a parabola. It has a y-intercept of 2, and it goes like this. Something like that, anyway. Just make that a little more symmetrical. Okay, so the intercepts, and you can get that right off your calculator, the intercepts are at 2 and -2. Okay, so that's great. Again, you can analyze the graph. You could actually figure out the x-intercepts if you wanted. Remember, the x-intercepts are when y equals 0. Lots of ways to do this, but this is what this graph looks like. Now, let's draw the square root graph in blue then. Now, remember we kind of said points, okay, when y equals 0, the two graphs intersect. When y equals 1, the two graphs intersect, right? Because the square root of 0 is 0, and the square root of 1 is 1. Okay, so those are the invariant points. Now, remember, these coordinates, those y coordinates, are in between 0 and 1. When you square root them, the square root is higher, so there's this little bubble here where the square root graph is higher. Okay, then after that it's lower. Okay, and then the next point, so this point, the y-coordinate is 2. So on the blue graph, it's going to be square root of 2, which is about 1.4-ish, so about there. Okay, so this is what you'll see on your calculator when you graph these. You see a graph kind of like that, and then notice there's the two regions where the square root graph is higher, and then that middle region where the square root graph is lower. So the domain and range, okay, so of the original, okay, the domain is x is an element of the reals, and y is less than or equal to 2. Okay, that's the original. So on the square root graph, okay, the domain was, oh look, it's from -2 to +2. So -2 x to +2, because that is where the y coordinates are positive on that particular graph. Okay, and then the range for this, it starts at 0, and then that is, of course, square root 2. So the range was 0 up to the square root of 2. Okay, and again, that's just because that guy there, we're square rooting all the y coordinates, right? Okay, so that's that particular graph. Kind of neat. Okay, next up we have a parabola, x squared minus 1. So that looks a little more normal for what we're used to. So -1, okay, square root, so 1 up, 1 over. Okay, and then so it kind of looks like this. So that is x squared minus 1. Now if I want to take the square root of that particular graph, remember square root of 0 is 0, so those two points intersect. Okay, when y is 1, those points are also going to intersect, so there and there. Okay, now the square root graph is taller for 0 to 1, and then shorter for the rest, so then it looks like that. Okay, and there you have it. So when you graph it on your calculator, you'll see something similar to that. Okay, perfect. Okay, and then the domain and range. Okay, the domain of the original, and then the root f of x. So I guess we could just say f of x. It's probably easiest. Okay, so the domain is x is an element of the reals, and the range is y is bigger than or equal to -1. Okay, so then for f of x, the domain, if you look, there's two separate parts. So x is either bigger than or equal to 1, or smaller than or equal to -1. Okay, so there's the two parts, and then of course the range is y is bigger than or equal to 0. Awesome. Alright, next up. Okay, so once a graph of a function is given, drawing the graph of the square root function is fairly straightforward. Simply square root all the y coordinates of the original. There are patterns to watch for. You can review the table on page 9 for your reference. So back a few pages, remember that's when we said when the graph was between 0 and 1, the square root graph is higher, etc., etc. Okay, so the example here, graph the square root function given the original graph. So number 3, given the following graphs of the functions, draw the square root of both functions. So this first one is just f of x. Now, first thing to notice is that each tick is 0.5. That's kind of important. Sometimes I miss that. So, okay. Anyways, might as well stay with orange. Okay, so what we're going to do is we're going to square root the y coordinates. So the orange graph will not exist way down here because when you square root the y coordinates there, square roots of negatives doesn't work. Okay, square root of 0 is 0, so that graph starts here. Now 1 is here. Okay, so the square root of these guys is bigger, so the graph kind of does that. And then for over here, the square root is smaller, so I've kind of, it's a little bit too much of a bubble, but that's okay. Okay, square root, so it kind of goes like that. All right, and that is a reasonable sketch of this graph. All right, so now we have the second one, g of x is a parabola. Okay, so square root of 0 is 0. Okay, the orange graph won't exist down here because the y coordinates are negative. Okay, so square root of 0 is 0, square root of 1 is 1. So we can put those 4 points on right away. So then the square root graph bubbles higher here and then out. Higher here and then out. And those are reasonable sketches of these graphs. Perfect. Okay, so summary. You can use the values of f of x to predict values of root f of x and to sketch the root f of x graph. Okay, the key values to consider are when the original function is 0 and 1, because those will be invariant points. Okay, the domain of root f of x consists of all values in the domain of the original graph f of x for which the y coordinates are bigger than or equal to 0. Okay, the range of that consists of all the square roots of all values in the range which are defined. So again, the square roots of positive numbers. And then the last one, the y coordinate of all points on the graph of y equals root f of x are the square roots of the y coordinates on the corresponding points on the original graph. Awesome. So I want you guys to practice this section. It's on page 86. Start with those numbers. Remember, you can always do more. If you think you're struggling, the answers are in the back of your textbook. So again, use your textbook or the PDF document in your workspace card. The greatest part about the workspace, remember, you can print them and then write all over it. So then you're not transferring to loose leaf all the time. But again, that is completely up to you. Thanks, guys. This is section 2. We'll see you next one. Thanks.